application what he tried. So yeah. So here what I want to say is electrode selection will be a very critical parameter to know or to find the performance of the direct wastewater treatment. Yeah, this you may be very much familiar. There are different methods to treat wastewater, especially direct wastewater also. So if you come to chemical methods, chemical coagulation can be used. Can you name some chemical coagulants? Alam, ferric sulfate. Okay, so we have a lot of chemical coagulants that can be used to form the flocks, and it will be forming the coagulants and it will be staying as a sediment, or sometimes we can see in the top also as a flock. Then we can remove all those flocks and sediments and we can have clear water, clarified water, treated water. Okay. So what about now next method, membrane method? We have second method like membrane separation. Or made of membrane is semi-permeable nature. It permits certain component to pass through. It does not permit certain component to pass through. That will be retained on the surface of the membrane itself. That's a basic principle. Okay. My doubt is this membrane can be only from polymer or what may be the membrane material? Okay, depending upon the particle what you want to retain, actually we can change the membrane. I'm asking membrane material. What can be the material for membrane preparation? Whether it can be only polymer. Have you come across only polymeric material membranes? Okay. Okay. And no, like ceramic membranes are there, metallic membranes are there. Metallic membrane, can you tell some metallic membranes? Have you seen some metallic membranes? In our mechanical operation lab, we have sieves. That is also membrane only because it is permitting certain particles to pass through. It is not permitting certain particles to pass through. It will be retained on the top because the particle size is bigger than the pore size of the metal screens. So it can be metal screen. Okay. So it can be metallic in nature, it can be ceramic in nature, it can be polymeric in nature, it can also be liquid nature. Have you come across liquid membranes? No. Yeah. So liquid membranes also we can prepare. Actually, that we got emulsion. Do you have idea about emulsion? You may be familiar, I think. So yeah, emulsion means actually two immiscible liquids you can take. For example, water and kerosene. Okay. So water and kerosene are two different phases, two different solvents. They have density difference. By mixing them together, they may not form a homogeneous solution. But at very high speed, when you mix them together, oil and water or kerosene and water, when you mix at very high speed, like 5,000 rpm, 10,000 rpm, there will be milky shake. So white milky shake will be formed. That looks like homogeneous phase. Okay. Only talk naked eye. When we mix it and we take and see, it will be looking like a homogeneous phase, like milky shake or something. But when you take the microscope and when you see take a droplet of liquid and when you see at the microscope, you can see two different phases. What are those? Continuous phase and dispersed phase. Continuous phase may be water. Okay, on that water, you can see some oil droplets, small minute oil droplets. Because of shaking, the oil molecule has broken into small tiny molecules. That can be seen only in microscope. That is called as emulsion. Okay. So that emulsion can be made as membrane. Okay. So that including some carrier molecules or including some emulsifier to make the emulsion very stable for long time. Okay. This emulsion what we are preparing on oil and water, it will be looking like a homogeneous phase only for short time. For half an hour or 1 hour, when you keep there and we can measure it. Okay. For half an hour, 1 hour, it will be looking like homogeneous phase. After 1 hour, you can clearly see two distinct phases. Okay, one will be oil, one will be water. Where you can see the oil phase? Top or down? Oil phase. Top. Why? Density is lighter than water. So we will get it splitted. But when we want to use for industrial application, batch operation will be doing only for half an hour or 1 hour. That time no issues. You can take some feed, you can take some emulsion, you can have a stirring, so that this whatever component we want to remove from the feed will try to get attached on this liquid membrane, emulsion membrane. That all things can happen within half an hour. Because emulsion is stable for some time. But when we use it for industrial application, for continuous application, what happens? This emulsion will be degrading or there will be two distinct layers will be formed within half an hour. Then how we can use for industrial purpose and continuous purpose? What should be the factor now? Emulsion should be very stable in nature. It should be stable even for 2 months, 3 months, or at least for a week, 7 days or something. So that one process at least we can go over. For stability, emulsion stability will be playing a very big role. For that, we can add some emulsifiers. Okay, like the carriers we can add. So this emulsifier will make the emulsion to be stable for a long time. The liquid membrane will be stable for a long time. Then we can add some carrier. This carrier will go attached. The carrier will be very selective in nature. This carrier will take some component from the feed mixture what we have given. It will be very selective towards one particular component. Your feed may be having a number of components, A, B, C, D, something. So this carrier will go attached with A alone. So now A is getting attached on the liquid membrane. The water which is coming out, no, that will be having only B, C, D. So what happens now? Selective adsorption of A has been happened on the membrane surface. It is one type of separation, purification. Like so, we can use membrane. So you have seen the advantages and show you. Every method has its own advantages and disadvantages. Now today sir was telling you membranes are not anymore. They are not going to recommend. Why? Was telling membrane studies may not be recommended in future. Why? He was asking that down. I think. What happened? What's the problem? Yeah. So the rejects, which is retained on the membrane, that disposal will be a very big problem. Okay. And it has a lot of valuable content also. And we have to see how to recover valuable content from the reject. All those things has certain, it is very complex in nature. Though membrane process is very simple, just one sheet of membrane may be sufficient to do some studies. One filter paper may be sufficient to do some study. Okay, it takes preparation takes place. But what about in continuous application? What about the environmental impact? So that will be server study. The reject studies has to be improved. Because of that, in Delhi, I think they are not encouraging this membrane studies or those things you study. So next is regarding biological methods. Biological methods also, in the morning it was very detailed lecture. So like UASB means it is upflow sludge blanket. So that method most widely used for wastewater treatment. In that case, what biological methods? What is the advantage of biological methods? What is the advantage of biological methods? Morning you had a very detailed lecture on biological systems. Less environmental impact. Why? Can you please tell me why is that less environmental impact? Very good. Because biological materials are from nature only. So when we dispose them in nature again, after using for our process, it's not going to degrade our environment. That is a very big advantage of biological process. Though it is time consuming or a lot of effort has to be taken to do those studies, to develop them, to inoculate wastewater, to cultivate them, all those things. But it's very friendly. Mostly it's friendly. 95% of the microorganisms are very friendly. Only 5% will be very toxic to the environment. Okay? That is biological system. Coming to Rahul's work, it is electrocoagulation. You all are very much familiar about electrocoagulation. So I'll go to this slide I will give you. This is just comparison between what is the advantage and disadvantage of different processes. For example, when you take membrane separation, it is a very simple method. I told you with a sheet of paper, sheet of filter paper, sheet of cloth, like that it may be sufficient to do some studies. Then it will be operating at mild condition. We can do at room temperature. Other studies, no, like distillation, all it is very heat intensive process. But membrane we can do and operate at room temperature. So these are the advantages and these are the disadvantages. Can you tell some disadvantages like what does low stability mean? What do you mean by low stability? He is membrane expert, no? Tell me what is low stability in membrane? What do you mean by low stability in membrane? That is fouling, no? That is fouling. Yeah, it is rate controlled process. That's also one disadvantage. But what I want to tell is low stability means with respect to chemical stability and mechanical stability. Because it is a membrane, most probably it may be polymeric material, or it may be like ceramic, or it may be some metallic membrane. So when it can be done in many ways, no? Okay. So what are the different methods? Usually, or conventional methods to do the wastewater treatment, which is having high amount of COD, BOD, and pH or order or color. So many parameters are there. We have to monitor all these parameters, then only we can leave it out. We know that pollution control boards, no? Yesterday one participant, Ramya Shankar, she was working in Kerala Pollution Control Board. So that is actually Central Pollution Control Board with help of State Pollution Control Board. They will be having some, they will be designing some factors. If it is chromium, how much it can be present in the water which is coming out of the industry, or which what we are leaving to the water source. Like every heavy metal, even COD, BOD has certain limit, then only we can dispose to the water sources. Like that. So here in this paper, we want to tell that untreated dairy effluent untreated diary effluent can be treated using again the same technique, electrocoagulation. But in industry, they have used biological method, aerobic and anaerobic method. But here, Mr. Rahul want to try electrocoagulation method for the same diary wastewater. What we have yesterday we have seen the wastewater, all those things, no, for that. So he tried electrocoagulation. That is a method what we are going to see in this paper. Second, actually, this electrocoagulation is an indirect wastewater treatment method that employs anode and cathode made of iron electrode or aluminum electrode. Commonly, the electrodes will be iron or aluminum, or we can have iron plus copper, like that. We can have different type of metals also. Now, in this paper, one innovation he tried to do. That innovation is nothing but he is trying to develop alloy electrode. Okay, he is taking aluminum, casting, he is molding that aluminum. Again, he is taking copper, he is bringing to the molten stage. Then he is adding this aluminum and copper together. That metal is alloy electrode. It will be like a homogeneous nature, but it has two content in it: aluminum content and copper content. That is the innovation what he tried. Okay. So yeah. So here, what I want to say is electrode selection will be a very critical parameter for to find the performance of the diary wastewater treatment. Yeah, this you may be very much familiar. There are different methods to treat wastewater, especially diary wastewater also. So if you come to chemical methods, chemical coagulation can be used. Can you name some chemical coagulants? Alum, then? Ferric sulfate. Okay. So we have a lot of chemical coagulants that can be used to form the flocks, and it will be forming the coagulants, and it will be staying as a sediment, or sometimes we can see in the top also as a flock. Then we can remove all those flocks and sediments, and we can have the clear water or clarified water or treated water. Okay. So what about now next method, membrane method? We have second method like membrane separation process. That also you are familiar now. What is membrane separation method now? It is a physical barrier. Okay, it's a physical barrier. It can be made of metal. Polymer. Polymer everyone knows. Nylon 6. Even in our house, no, we are using tea filter, coffee filter, all. That is made of nylon 6 all. Okay. So polymeric material you may be knowing. Membranes are made of, membrane is semi-permeable nature. It permits certain component to pass through. It does not permit certain component to pass through. That will be retained on the surface of the membrane itself. That is a basic principle. Okay. My doubt is, this membrane can be only from polymer, or what may be the membrane material? Okay. Depending upon the particle what you want to retain, actually we can change the membrane. I am asking membrane material. What can be the material for membrane preparation? Whether it can be only polymer? Have you come across only polymeric membranes? Then? Okay. No, like ceramic membranes are there, metallic membranes are there. Metallic membrane, can you tell some metallic membranes? Have you seen some metallic membranes? In our mechanical operation lab, we have sieves, no? That is also membrane only, because it is permitting certain particles to pass through. It is not permitting certain particles to pass through, because it will be retaining on the top, because the particle size is bigger than the pore size of the metal screens. So it can be metal screen. Okay. So it can be metallic in nature, it can be ceramic in nature, it can be polymeric in nature, it can also be liquid nature. Have you come across liquid membranes? No. Yeah. So liquid membranes also we can prepare. Actually, that we call emulsion. Do you have idea about emulsion? You may be familiar, I think. So emulsion means actually two immiscible liquids we can take. For example, water and kerosene. Okay. So water and kerosene are two different phases, two different solvents. They have density difference. By mixing them together, they may not form a homogeneous solution. But at very high speed, when you mix them together, oil and water or kerosene and water, when you mix at very high speed like 5000 rpm, 10,000 rpm, there will be milky shake. So white milky shake will be formed. That looks like homogeneous phase. Okay. Only to our naked eye. When we mix it and we take and see, it will be looking like a homogeneous phase, like milky shake or something. But when you take to microscope and when you see take a droplet of liquid and when you see under the microscope, you can see two different phases. What are those? Continuous phase and dispersed phase. Continuous phase may be water. Okay, on that water you can see some oil droplets, small minute oil droplets. Because of shaking, the oil molecule has broken into small tiny molecules. That can be seen only in microscope. That is called as emulsion. Okay, So that emulsion can be made as membrane, okay? So that including some carrier molecules or including some emulsifier to make the emulsion very stable for long time. Okay, this emulsion what we are preparing, no, with oil and water, it will be looking like a homogeneous phase only for short time, for half an hour or 1 hour. When you keep there and we can measure it, okay, for half an hour to 1 hour it will be looking a homogeneous phase. After 1 hour, you can clearly see two distinct phases. Okay, one will be oil, one will be water. Where you can see the oil phase? Top or down? Oil phase. Top. Why? Density is lighter than water. So it will be getting splitted. But when you want to use for industrial application, batch operation will be doing only for half an hour or 1 hour. That time no issues, you can take some feed, you can take some immersion, you can have a stirring so that this whatever component we want to remove from the feed will try to get attached on this liquid membrane, immersion membrane. That all things can happen within half an hour because immersion is stable for some time. But when we use it for industrial application, for continuous application, what happens? This immersion will be degrading or there will be, what is it? Two distinct layers will be formed within half an hour. Then how we can use for industrial purpose or continuous purpose? What should be the factor now? Immersion should be very stable in nature. It should be stable even for 2 months, 3 months or at least for a week, 7 days or something. So that one process at least will get over. For stability, immersion stability will be playing a very big role. For that we can add some emulsifiers. Okay, like that carriers we can add. So this emulsifier will make the emulsion to be stable for long time. So liquid membrane will be stable for long time. Then we can add some carrier. This carrier will go attached. The carrier will be very selective in nature. This carrier will take some component from the feed mixture what you have given. It will be very selective towards one particular component. Your feed may be having n number of components, A, B, C, D something. So this carrier will go attached with A alone. So now A is getting attached on the liquid membrane. The water which is coming out now, that will be having only B, C, D. So what happens now? Selective adsorption of A has been happened on the membrane surface. It is one type of separation, purification, like that. So we can use membrane. So you have seen the advantages, I will show you. Every method has its own advantages and disadvantages. Now today sir was telling no, membranes are not anymore, they are not going to recommend. Why? He was telling membrane studies may not be recommended in future. Why? He was asking that doubt, I think. What happened? What's the problem? Yeah. So the rejects, no, the which is retained on the membrane, that disposal will be a very big problem. Okay. And it has lot of valuable content also. And we have to see how to recover valuable content from that reject. All those things has certain, it is very complex in nature. Though membrane process is very simple, just one sheet of membrane may be sufficient to do some studies. One filter paper may be sufficient to do some study. Okay, it takes filtration takes place. But what about in continuous application? What about the environmental impact? So that only server study. Okay, the reject studies has to be improved. Because of that, in Delhi, I think they are not encouraging this membrane studies or those things you were studying. So next is regarding biological methods. Biological methods also, morning it was very detailed lecture. So like UASB means it is upflow aerobic sludge blanket. Okay, so that method most widely used for wastewater treatment. In that case, what biological methods? What is the advantage of biological methods? What is the advantage of biological methods? Morning you had a very detailed lecture on biological systems. Pardon? Less environmental impact. Why? Can you please tell me why it is having less environmental impact? Very good. Because biological materials are from nature only. So when we dispose them in nature again, after using for our process, it is not going to degrade our environment. That is a very big advantage of biological process. Though it is time consuming or lot of effort has to be taken to do those studies, to develop them, to inoculate, means what is it, to cultivate them, all those things. But it is very friendly. Mostly it is friendly. 95% of the microorganisms are very friendly. Only 5% may be very toxic to the environment. Okay, that is biological system. Then coming to Rahul's work, it is electrocoagulation. You all are very much familiar about electrocoagulation. So I'll go to what is electrocoagulation. Yeah, before this, I think this slide I will give you. This is just comparison between what is the advantage and disadvantage of different processes. For example, when you take membrane separation, it is a very simple method. I told you with a sheet of paper, a sheet of filter paper, a sheet of cloth, like that it may be sufficient. Okay, to do some studies. Then it will be operating at mild condition. We can do at room temperature. Other studies, no, like distillation, or it is very heat intensive process. But membrane we can do in operate at room temperature. So these are the advantages and these are the disadvantages. Can you tell some disadvantages like what does low stability mean? What do you mean by low stability? He is membrane expert, no? Tell me what is low stability in membrane? What do you mean by low stability in membrane? That is fouling, no? That is fouling.
Output will be reduced based on time.
Pardon?
Output will be reduced based on time.
Yeah, it is rate controlled process. That also one disadvantage. But here what I want to tell is low stability means with respect to chemical stability and mechanical stability. Because it is a membrane. Most probably it may be a polymeric material, or it may be like ceramic, or it may be some metallic membrane. So when your feed is corrosive in nature, acidic solution, alkaline solution or something, this may not have stability with respect to life. Easily they may get degrade. Okay. So then thermal stability also. Since we are operating mostly in room temperature, this was designed for operating in room temperature. When you increase the temperature, thermal stability may not be there. So this type of problems are there in membrane separation method. So every method has its own merits and disadvantages. Okay. So this is the slide. We'll be dealing that. Now, do you think electroporation is a very new technique which was invented recently before some 3 decades or 4 decades like that? No. Okay. See here, in 1889 itself, electricity employed water treatment was first proposed in UK. Electricity employed means it may be electrolysis also. Some electricity concept they are using for water treatment or wastewater treatment or splitting of water. All those things was happening in 1889 itself. Okay. Later what happened? This electrocoagulation was first patented. It got its first patent by US in 1909. More than before 100 years, we got first patent for electrocoagulation. But still we are doing, and there are a lot of scope for electrocoagulation also. You have listened to all the online and offline session, no? There are a lot of scope for electrocoagulation. Yeah, see, electrocoagulation was successfully applied in a large-scale drinking water treatment in US in 1946 itself. But the problem is it was not gaining much popularity because of the potential required, electrical potential required. In my first class also I told that this electrocoagulation needs some electrical gradient, no electrical potential. Once you give high electrical potential, automatically the performance will be high. But can we give high electrical potential? We know that electrical potential is a driving force. When we increase the driving force, automatically the performance should be high. If you give 30 volt, if you give 50 volt, which will be giving best performance, 30 or 50? 50. So electrical potential is a driving force. But can we give 50 or 60 or 70 like that? Can we go on increasing? No. Why? Why can't we give a high electrical potential? Energy consumption increases. Since we are using the electrical energy, the energy consumption will be increasing. So we have to optimize certain parameters. Otherwise, it will not be cost effective. So because of this reason only, it was not much popularized. Okay. Then what happens? There are a lot of electrochemical methods for wastewater treatment. Can you name some? Wastewater treatment electrochemical methods. Till now, have you come across any electrochemical methods for water treatment? What? That is coagulation. No, electrocoagulation. Other than electrocoagulation, in our online offline classes, did you come across any electrochemical methods for water treatment, wastewater treatment? No. Any other electrochemical methods other than electrocoagulation? What? Tell me. Electropentons is one method. Then electrosorption. I told about capacitive reionization method. No, that is one electrochemical method. Electroreduction, electrooxidation. Being specialist in that, there are a lot of electrochemical methods are available. In that, electrocoagulation is one among that. Okay, so that electrocoagulation is very simple method. Here you can see the setup, no? Only you want 2 electrodes, 1 reactor. That reactor can be a simple beaker in our lab. Okay, only when we want to scale up or multiply only, when we want to treat large amount of water, we have to think about the big setups. Otherwise, all the tests can be handled with one simple beaker, 2 electrodes and some potential what we are giving. Okay, so it is very simple in nature and small footprint. It needs very less space, all those things. And we can treat large amount of wastewater, okay, with limited chemicals. You can highlight that with limited chemicals. Here we are not using any chemicals additionally, okay. Because of that, sludge formation will be less, so that we don't have any secondary pollutant. After treatment, when we are left out with large amount of sludge, that needs to be treated before leaving to the environment. So with limited chemicals, we are doing this process. Because of that, no sludge formation or minimum sludge formation. Next is regarding scalar possibility. Okay, you have seen lot of reactors, no? We can do in multiple reactors. We can have stacked electrodes, more number of electrodes, monopolar, bipolar, lot of electrode configuration, electrode material, everything we can play a role. Okay, we can play innovation in those parts. Okay. Yeah. Now coming to this exact work, development of aluminum copper alloy electrodes. So what he has taken is, see here. This is the molten metal. We are melting, no? We are melting aluminum separately, copper separately. Then what happens? This in the required ratio. For example, he has taken 3 different combinations: AC1, AC5, AC10. AC1 means aluminum will be 99 in composition. 1 will be copper. Just 1 will be copper. AC2 means aluminum will be 95, 5. AC5. AC1 means 1% is copper, 99% will be aluminum. AC5 means 95 will be aluminum, 5 will be copper. AC10 means aluminum will be 90, copper will be 10. Like that he tried 3 different combinations by just casting them, then pouring that molten metals, that cast alloy material will be poured on a casting tray. Then we are taking that electrode material, it will be like a sheet, then we can cut into different shapes what we want. So this is the shapes what he has made. It is 10 centimeter in height and 2.5 centimeter in width and 0.2 centimeter in thickness. Very thin sheets only. Okay, it will be like a small sheets. He has taken these electrode sheets. First combination is aluminum itself. Whenever we do some study, we have to study from the base. Okay, this is pure aluminum. This is pure copper. Second one, third one is AC1. Then fourth is AC2. Fifth is AC10. Like that, he has selected different electrode combination, and this electrode combination has been inserted in this electrocoagulation cell, and he is giving some potential like 30 voltage. I think it is written down. So 30 voltage has been given as electrical potential, and coagulation will be taking place. Electrocoagulation will be taking place. The principle is, yeah. Before going to that reaction, anodic and cathodic, now whenever you read a paper, what will be the first concept we have to learn? Now you are very much familiar. We gave some idea. ACT Atal has given some method how to refer a paper. So when you read a paper, what you should be knowing first? You should be knowing what is the methodology is followed. That is key principles of practices. What type of practice they have done in this paper. So here what type of practice we are doing? We are going to treat dairy wastewater. Okay. Second thing, what method we are going to use? Electrocoagulation process. Then what type of what is it? Practice we are going to do? New practice. Scope for alloy electrode. Okay, like this you have to segregate the paper with respect to the scope. Okay, key practices or principles. Yeah, this is the electrode reactions. What is happening? This also, I think yesterday I was asking some question. They were able to answer. Anode means what happens? Release of electron will be taking place. In anode, what we are having? If it is example, it is like copper. If your anode is copper anode, then the release of electron will be taking place. Okay, in then this copper and 4 electrons will be released. This released electrons will be will be joining with water and will be forming hydroxides. And this copper, no, in hydrolysis process, this copper 2 plus and water will be reacting together and they will be forming copper oxide. Okay, this copper oxide, this hydroxyl group, no, which is formed only, they will be merging with the impurities present in the water and they will be trying to form flock, and the flock will join together and they will form like a sediments or those things. Okay, so this reaction you will be knowing. Now coming to the prepared electrode characterization. Okay, so now alloy electrode has been prepared. 5 different combination study has been done. First is aluminum, second is copper, AC1, AC5, AC10. So regarding the electrode characterization, so here, yeah, first diagram is regarding XRD. Okay, that XRD spectrum shows that XRD, what we can confirm, yesterday we are not having XRD in our lab, no? But you may be knowing what is the application of XRD spectrum. Yeah, we can find out whether they are crystalline in nature or amorphous in nature. So this XRD has been taken in different branch angle from 10 to 90 degree and 10 sorry. Can you see here 5 different peaks? 5 different peaks are there. Where it is more visible? The first diagram, second diagram, the third diagram. Where is more visible? Second diagram. Third diagram. So what I want to tell here is the alloy electrode AC1, AC5, AC10 has been studied for XRD spectra. After studying, we will come to know that AC10, no, AC10 is having more clear visible peaks, okay, and it is confirming that all the peaks, all the AC1 to AC10, it is having the crystalline structure only. Because of making them in alloy, nothing is going to change. They all are confirmed for its crystalline structure. Also, alloys also we can call alloys in different names. Okay, like crystal we can call it rhombus, tetragonal like that. No, so alloys also we can call it different names. This is catriatite. Catriatite is one type of alloy. So this groups, catriatite is one type of alloy. Okay. So this all peaks confirms that alloy, it has been alloyed. Two metals have been alloyed and they belong to catriatite group of alloys. Okay. As the copper content increases, the peaks are more visible. It says that more crystalline structure or something like that. Okay. That is the difference in these three diagrams. Is it okay? It's clear for you? Rahul likes to explain more? No. Okay. Okay. Now coming to, after that we can discuss. Okay. If any doubts we can discuss. Now coming to electrode hardness. Electrode hardness, this alloy electrode was subject to Vickers hardness test. Okay. So it will be like a cup, Vickers cup. We have to keep our electrode there and we have to give certain force. Okay. That force given is 0.5 Newton and the holding time will be 15 seconds. Okay. We are giving some force and we are giving some time. Then we are finding out its hardness. Okay. Whether it is hard or it is easily gets break or some damage or something has been happening on the deformation is happening on the surface. So we came to know that as the copper content is increasing from 1 to 10%, the hardness is getting increased. Okay, we know no, better than aluminium, copper will be having a rough surface and hard in nature. That is getting inferred from here. Okay, as the copper is getting increased, the hardness of the electrode surface is getting increased. Okay. So among all electrodes, aluminium has least hardness, that is 358 megapascal. Okay, 358 megapascal. And compared to aluminium, AC1 will be having more hardness, then AC5 will be having the next hardness, AC10 will be having the next hardness, highest hardness, copper will be having the highest hardness. Like. So this is regarding the surface morphology study. For what we will be using the SEM analysis? To know the surface structure. Before reaction how it looks, after reaction how it looks. For example, when you take some adsorbent, before adsorbent is not, for example, absorption of heavy metals or dyes from wastewater. That adsorbent may be activated carbon. Before absorption, the activated carbon can be seen in the cell. Scanning electron microscope, the surface may be having some structure. But after absorption of dyes or after absorption of heavy metals, there may be some deposit, no? Because it's surface phenomena. These heavy metals might have attached on the surface of that time we can see some type of roughness or some distribution of some material on the surface of the electrode. That is the purpose of this morphology study. So here, what he wants to confirm, what he wants to infer is that the morphological analysis of AC10 electrode has less surface damage at the reaction zone, reaction zone than all other alloy electrode combinations. He is telling that surface damage is very less in AC10. Okay, can you tell me why? Surface damage is very less. Why? AC1, AC5, AC10. He is telling that surface damage will be very less in AC10 compared to AC5 or 1. What is the reason? Copper has the more hardness. Okay, so it will not easily get damaged or destroyed. That is the reason. So he is confirming that from SEM image. Okay, that SEM image which is having that last one. Okay, so it is having less surface damage. This is regarding pH of the pH effect for the different alloys. So here what it is inferred is aluminum electrodes will be having pH. Initial pH will be something. Initial pH is around what is the initial pH? Rahul? How much? It is not mentioned here. Okay, 6 point. Initial pH of the dairy wastewater will be 6.6. Okay. So final pH will be in alkaline range. Why it is in alkaline range? Hydroxyl. Okay, the formation will be there. So that hydroxyl formation is less in case of aluminium combination compared to copper combination. Okay. Why? Can you tell me why? I'm just telling that in aluminium combination, the hydroxyl formation is less. Okay. So the final pH may be going up to, yeah, it will be going up to 7.75 to 8. Initial pH was 6.6. Then what is it? The final pH will be going up to 8. Okay. But in copper case, when we add copper, the final pH is going up to 9. What may be the reason for that? It means more hydroxyl has been formed. Okay. What may be the reason? What may be the reason behind that? Why more hydroxyl is formed in copper case? Pardon? Everything is there in that slide itself. What it is written? The formation of various metal hydroxide complexes in the wastewater. From the figure, it is inferred that wastewater is more basic when using copper electrode from aluminium electrode at end of the processing time. Okay. In this alloy electrode, the percent of release of hydroxyl ion for both aluminium and copper. Yeah. Actually, what you want to tell is release of hydroxyl will be more in case of copper electrode. Because of that only the OH group is getting more formed and it is pH is going up to 9. Okay. When you have more hydroxyl formation, what happens? Efficiency will be less or high. Aluminium is giving more hydroxyl formation compared to copper. Okay. So what is the inference from that? When you have more hydroxyl formation, copper hydroxide or something, what will be the benefit out of that? You have more hydroxyl groups, so more flocks will be formed, more separation will be happening like that. Okay, that is the inference from this diagram. And electrode loss, you can tell me now. What is electrode loss now? Electrode dissolution will be taking place. So aluminium will have some dissolution and copper will be having some dissolution. So where we can expect more electrode loss? Aluminium. So aluminium will be having more electrode loss. So the electrode life will be less in case of aluminium. That is the main reason he tried this innovation. Okay, because aluminium electrode is a form, even compared to aluminium, actually iron is most commonly used, but it has lot of hydroxyl formation problem. Okay, loss will be more easily. We have to every time we have to replace the electrode. In order to overcome that, only people went for aluminium. Aluminium is cheap as well as it is not much dissolution compared to iron, and it is not harmful also. Okay, not much harmful. Because of that, only people started moving to aluminium. Now he is telling, now what his intention is to use the electrode for long time. Okay, because it gets dissolution, no, it gets loss of electrode will taking place. That he likes to minimize. So he wants to confirm that this. You want to confirm that electrode loss will be less in case of AC1, more will be in case of AC1 compared to AC10. AC10 will be having less electrode losses. Then reaction time. Reaction time is also very important parameter. We have to take very less time for the reaction to take place. Okay. So what reaction time? Again, where it will be less in case of AC10. Okay, because it is having more dissolution of hydroxide. It is very hard in nature. It is not going to dissolve very easily compared to the other combination. So the reaction time taken place will be very less because more hydroxyl groups are forming. No, because of that, easily the flocks will get formed and very easily the process will be completed. So less reaction time for AC10. Yeah, zeta potential. One more factor is there. What do you mean by zeta potential now? What is zeta potential? Why we want to measure the zeta potential? If zeta potential is high, what do you mean? Mohandas in Aravind. Surface charge. But what is the basic inference from zeta potential value? If it is high, what do you mean by that? Aravind? If zeta potential value is, no, I am not asking with respect to surface charge. If zeta potential is having a high value, what does it infer?
Stability is very less. Stability will be very less, so that the particles will be settled into the core.
That is zeta potential high. High.
Zeta potential high.
This reverse. Actually, no, just I'll explain. Okay. If zeta potential, it is reverse by Hastings. Okay. If zeta potential is high, the particles will be dispersed in nature. Dispersed in nature means everywhere throughout the solution we can have small particles dispersed in a very uniform manner. In that case, the system is stable. The solution is very stable in nature. So the zeta potential will be high or positive or something like that. When it is very less means, what do you mean? They are not dispersed in nature. Somewhere some clocks will be formed. It is not minutely dispersed everywhere. Somewhere more clock will be there, somewhere less clock will be there. It is not uniformly distributed. So the system is not stable. Okay. Once it is stable means it will be uniformly distributed. If it is not stable means somewhere more particles, somewhere less particle. For electrocoagulation, for any liquid system, whenever we study some liquid system, we want to have a stable system. Okay. We like to have that uniformly dispersed. Okay. For electrocoagulation, whether we want high potential or low potential, zeta potential. High potential. Why? Stable, if a system is stable, it means that all the particles are dispersed equally in the liquid phase. Okay. In that case, we tell it a stable system and zeta potential will be positive or it will be higher value. In electrocoagulation process, do we need all them to be in the dispersed nature or they want to collide with each other? Okay, so what type of potential we want? Lower. Okay, that only he likes to study, and he was confirming that the aluminium and alloy electrodes are better choice for for aluminium AC1, AC5, AC10 electrode goes low zeta potential, reducing the electrostatic interaction between the particles, allowing the particles to approach closely and produce more compact blocks. Okay? Since they all are having less zeta potential, they will be enhancing the flock formation and easily the coagulation will be taking place. That is the inference for AC1, AC5, AC10. Okay. Is it okay? Fine? Okay. Yeah. Then COD removal. Again COD removal also, it is confirmed that alloy electrodes are having better performance because of its long time, hardness, more hydroxyl formation. We have two type of hydroxyls now. Aluminium also will be degrading dissolution and copper also will get dissolution. So we can expect two type of hydroxyls coming out from the anode reaction. Okay, so we'll be having more type of multiple hydroxyls. This multiple hydroxyl will be enhancing the performance of sludge formation. Okay, so that was the sentence. And this all the results. Now application of the principle and practices. Here he has done some practice. He has taken some methodology. He has taken some field. Okay, and he has applied that methodology or that particular field for a particular purpose. Okay, that application is nothing but technological applicability and development of alloy electrodes for diary wastewater treatment. Alloy electrode is the main focused one here, and electrocoagulation mediated wastewater treatment. We are using the electrocoagulation method only small innovation, that is alloy electrodes. Okay. Then performance evaluation of the alloy electrode in diary wastewater treatment. We have evaluated the performance in terms of reaction time required, in terms of electrode loss, in terms of hardness of the electrode material, like that. Okay, in terms of performance also, COD removal also. So COD removal was the output parameter in what we are measuring the performance. So that COD removal was better for the AC10 compared to AC5 or 1. Okay. So this is the basic inferences from the paper. Conclusion, what is conclusion is? See, among aluminium copper electrode alloy combination, AC10 is the best choice among electrode combinations with turbidity removal of 81.64 and COD removal of 98.29 with minimal reaction time of 54 minutes. In 54 minutes, we can remove the turbidity can be removed 81% and COD can be removed 98%. Pardon? Volume treated. Volume of wastewater treated usually we 250. Is 250 ml of wastewater or 250 ml? So this is the results. And this copper electrodes, no? Copper electrodes are least efficient electrode with maximum turbidity removal of 66 when they are alone, when copper alone. Because copper alone, what is the problem? Why it is having less percentage? When you use copper alone combination, why it is having less percentage like 67 or something? Because it is very hard. The solution will be Then only we may get chance to publish the paper, to get patent and everything. So whatever he did is everything same. Electrocoagulation, many research work you have seen and many people are talking about electrocoagulation. Same thing only he is also doing. And we came to know that electrocoagulation first patent was obtained in 1909. Okay, so he has taken the very oldest technology. But still there is scope for improvement. He is trying some alloy electrode and he is trying to find out enhancing the performance of the electrocoagulation process. Especially what we want to do, we want to have very less time. Okay, continuously when we are doing, we have to take the performance in very less time, high performance, less time. And one more important factor, it should be eco-friendly in nature. Okay, that we have to check it because the electrodes, no, it is all made of metallic electrode. Other studies like what I was explaining in CBI, Arvind's work or Mohanraj's work, they will be doing some activated carbon type of electrode. That may not be much problem to the environment compared to this metal electrode. Metal electrode means they are persistent, no, they can't degrade easily. And especially we are making alloy, because this alloy work all it is little energy consuming process, we have to mold them in the furnace, all those things, but those things will be costly only during the initial steps. Okay, once the metal electrode is prepared, that electrode if it is having a life for 6 months or 1 year, then that particular problem will overcome. The cost intensive process, no, that will be overcome. Okay, so anywhere we have to compromise. It's not like that always we have to take cheap materials, we should not use some technology for modifying that. We can modify and we have like Shivasubramanian sir was telling everything we have to do some cost analysis. In batch, when we do for a small scale, don't need that, but when you're planning to do for like a pilot plant or scale, we should know what is the cost involvement in it. So this is the this also his first study only. After this also he has published, he has sent 2 papers. This very initial work what he has carried out after joining in this particular topic. So now takes. What are the key takeaways? What you have taken from this paper? What you have taken from this paper by knowing all this concept? He has studied reaction time, pH effect, then COD removal, performance in terms of COD removal, turbidity removal, all those things he has studied. So what is the take-away principle or concepts?
Different alloys can be.
Yeah, different alloy electrodes can be used for wastewater treatment. Next, what is the next? Using the electrochemical methods for remediating water. Okay. Next is like different electrode combination. What is it? Same thing only. Okay. Different electrode combination, alloy electrode, electrocoagulation, or we can change the reactor setup also. Now he is doing in continuous reactor setup. Earlier he was doing the batch only. Now he has designed a fabricated a continuous setup. I think he will be showing now. When we are going to lab, please show a setup. So initially it was done in very small scale. Now he has done for continuous setup and it is available in our lab. You can see that. Okay. Okay. Any other doubts? Thank you. So, yeah.
Regarding the other, quick 4 minutes reaction to the carbon 98%.
Yes.
Regarding copper, where 60% of the time.
He has shown only the optimum conditions. Actually, this is like paper discussion. No, initially he gave me some 40-50 slides. Then, since it is article discussion, we have reduced. The paper will be given to everyone. What was the time he is asking about the time for aluminium alloy? Just read it from the paper. Slide. The table, it is very small. I am not able to read.
And the graph also is there.
Which graph I will take it?
Bar diagram.
This.
No, bar diagram. Every electrode, if it is 1 centimeter electrode gap and 2 centimeter electrode gap, what is the minimum time? It is written on the top. So the black color is aluminum. First one is 1 centimeter inter-electrode gap and second is 2 centimeter. Copper is blue, AC1 is green, AC5 is red, and AC10 is magenta. So from that, you can see it is optimum reaction time to get maximum removal of CO2.
So reaction time is everything I have shown here. Only thing, one point I have left out here. By seeing the slide, I can come to know that the electrode distance also play a role. Okay, electrode distance. When we are reducing the distance, what happen? Performance will be high or low? Low. When we reduce the distance between the electrode, whether performance will be high or low? High. Because that the influence of the electrical field will be there. Then the more performance will be happening. So he has studied at 2 different electrode distance. One is 1 centimeter distance, one is 2 centimeter. He wants to confirm that 1 centimeter difference is having good result compared to the 2 centimeter, because electrode distance, as they are very close, that will be having more performance compared to wide difference. That is one. They have direct influence on the performance. Like our electrical field, what is electrical potential? Okay. He has used 30 volt here, I think, 30 volt. So these are the reactions. What's the
My doubt is regarding the casting of the.
Yeah, please.
So what is the temperature?
It should be high temperature. I think 800. What is it?
Aluminum and copper is bonding. We will be taking the rate. Like if we are taking 1 kg of wheat for malt, we need 1 kg minimum. So I am taking, if you take 10, I will take 900 grams of aluminum, 100 grams of copper, and both will be put in the crucible, and that is induction furnace. We use induction furnace for the melting. So that after like 1100 degrees, it will be in the molten state. In 700 degrees itself, aluminum will be in the molten state, copper is more high. So for surface like 900 itself, it will start melting. It's like around 1100 we get. So the entire system.
1100 for copper, no?
Both will be kept in the same crucible.
Oh, like that, huh? Because 700 to 800 may be sufficient for aluminium, but copper needs high temperature. Oh, so you're keeping both and having high temperature so that both will melt.
Both will be melted in the same crucible.
Now what's your doubt?
Mixing both methods.
Yeah. Actually, I was thinking like that. Means I assumed like that. Aluminium has to be molten separately. Copper will be they'll be in liquid phase now. Then how we are maintaining that ratio of 1:95?
We will be measuring the quantity before making. Like 900 is to 100, like 9 is to 1. Ratios will be taken by weight. And the uniformity of the alloy is determined by the process is called skill casting. When the entire subject is in molten state, we have a shear second above it, and we provide some mixing. Yeah, we can't keep it. It's very high temperature. So some agitator like in insulated inside and provide mixing so that the entire liquid form will be homogeneous, like somewhat ideal order. So then only we have to pour it to the glass.
So first you are just melting them, then you are stirring to make a homogeneous mixture, then only it will be taken to the casting. Okay. Any other doubt?
So I have doubt regarding the correction factor is provided in the research.
Correction.
Is that by some equations or?
That plus or minus you're telling?
Yeah.
That is actually, that is very important again. Whenever you publish paper, whenever you send paper, they'll be asking for the concurrent values. Like when we do titration all in our chemistry labs, we take 2-3 times, no? So we have to repeat the experiment minimum 3 times. So first time, for example, if you are having plus or minus value, see here. So this is 83.2 plus or minus 3.72. The meaning is the value, the initial value and final value. We are taking 2 to 3 times, no? The values will be lying between this plus or minus 3.7. That has to be done. That is called error bar also. Without this, they will not accept. They want us to repeat at least minimum 3 times for research. Any other doubts?
Experiment conditions are all right. Results also?
No, actually the same experiment has to be conducted. Same experiment has to be conducted minimum 3 times to know the error values. So we can't tell that exactly the percentage of removal was 86%. Okay, there will be some plus or minus. Okay, that should be the range should be given in the paper publications. Yeah. Actually, copper is costly also. Okay, copper is not so it is not having distillation property, and it is very costly also. It is very hard in nature, everything. Only thing, life of aluminium. Okay, we want to do something in increasing the life of aluminium electrodes. Okay, compared to iron, aluminium is most commonly used. Do you accept that? Compared to iron, aluminium is commonly used now. And aluminium also has that electrode loss problem. Okay, and it has good performance. Performance-wise, aluminium is good only. And but it has some sacrificial anode, no? So it has some loss. That loss, how to minimize? How can we use the electrode for long time? That is the focus. So we should try to incorporate some other alloy material like copper or something, only in small, titanium also. Okay, we can include only in small quantity. When we keep on increasing copper like 50-50, aluminium 50, copper 50, it will unnecessarily increase our cost. Performance may be increased. Okay, I told no, we have to do some compromising. Okay, because of performance, we can't do very costly methods or costly electrodes. We can't select it. Okay, economical balance should be there, environmental impact should not be there, as well as performance should be high. Like that, we can balancedly tell that our research is fitting to the current need or something. Like Rahul likes to add something.
Actually, we can't use small percentage of copper to meet this category balance because maximum according to some chart, mechanical chart, if you are mixing two metals to make a stable metal, we can't use 50% aluminum and copper together or 80%. Maximum possibility with the better strength of mixing is like 12% copper.
What may be the reason? Why can't we go for 20 or like
Because
what?
I made 15% also, but the electrode that I got is like just like brittle. It will break very fast. So the optimum time, optimum concentration, because of that only I saw 810, 810.
Yeah.
If I want beyond 10, what I observe is that it becomes, the value will not be stable, it will provide a small voltage. Because of that.
Only one thing I want to ask Rahul, it is like asking myself, now regarding the environmental impact, again it is a metal electrode, no? Like metal and aluminum plus copper. You are using long time so that you are trying to reduce the environmental impact. So what will be your next study so that participants may come to know how to balance the environmental impact problems? It is pure metal, no? Aluminum is pure metal, copper is pure metal. Can you tell some ideas to them that how it can be minimized?
Actually, I'm already explained about the electrode gaps, the reaction time and everything. The main use of using electrode values in the process is that you will end up in the metal flat temperature. And we again have to do some process to make it remediate without making any damage onto the environment. So what we have to do is that we have to convert that metal to some value-added products. So currently we are having the idea which is focused on the product development from the sleds which is generated. And we communicated on paper also regarding the same. I don't know whether we have to. We started on making products like pigments.
Okay, I will tell. I will tell. What is telling is, we know that that electrode is having loss. In that sludge, no, we'll be having a lot of aluminium materials, copper materials, a lot of things will be there. That is hazardous only. When actually we have taken the pollutants from the water phase, and we are now disposing in terms of solid waste. That is not good. So he's trying to do zero discharge. Zero discharge means no pollutant should be given to the environment. With that concept, he's telling that the sludge, whatever is left over, the electrocoagulated sludge, that sludge we can try to use for some beneficial things like biofertilizer preparation. Like yesterday, that Milma plant sludge will be there, no, after the biological methods. That is having a lot of biological content in it, and it is very toxic also. But they are using for farming purpose. He told, no, very beautiful gardens there by using the sludges, wastewater, all. It is happening, but it is not technically, means it is not proven. Okay, they simply use because they don't want to waste the sources. They are using the wastewater. They are used after some preliminary treatment. But here, what Rahul is technically or what is it, more focused on research is, he is taking that sludge material, some ratio of industrial sludge will be taken, and some ratio of this electrocoagulated sludge. What he is using, no, they are not using electrocoagulation. They are using biological methods. From that, the sludge will be having a lot of biological properties. That biological sludge plus this electrocoagulated sludge what is having, then plus some what is that industrial waste or some vermicompost, all those things has been joined. Some ratio we are trying now. The work is going on, and these are the B.Tech students who are doing in that. So they are trying to develop some fertilizer, commercial biofertilizer, which is accepted, which will be accepted by everyone, or which will be having the properties of fertilizer. The commercial fertilizer we are in trial now. They are using coal wash, coal industry wastewater. No, the coal wash slurry they have used. This Milma sludge we are using, and we are doing some works on it. Okay? That is one. So we should try to do like that. Waste is generated. Now we have to try. Like one more, Ramya Shankar was telling that her sludge, no, that electrocoagulated sludge, it has some metal content in it, and she is using for some brick, that brick composite. Yeah. Yeah. So we have to find the application for the sludge left over. We should know the toxicity. The sludge what we have after this process, after this particular process, it is going to have aluminium in it, it is going to have copper in it. What may be the toxicity? Okay, if it is having toxicity, high toxicity, then we can't dispose anywhere. In that case, at least we can convert into some other product. Okay, like composite brick or some fertilizer. Fertilizer means Some plants may be tolerant to some extent to the copper or aluminum, like phytoremediation or something. They may be able to survive. Okay. Only thing we have to see, it is not getting bioaccumulated or biomagnified, all the metal particles. That only. Okay. So that is his work. And we should try to use maximum the electrode. That's all. Okay. Thank you all. So after this, we'll be going to lab for practical sessions using electrochemical workstation. Okay, that electrochemical workstation is any type of electrochemical study you do, whether it is electrocoagulation or electrosorption. Finally, we have to do analysis, no? Like CV curves or how the COD removal, all those analysis we can do, like zeta potential measurement. We want certain analytical instruments. Those analytical instruments are available in my lab. One is electrochemical workstation, zeta potential analyzer, and few more equipments are there like sonicator, all those things. They'll be explaining you, they'll be showing you. Okay, thank you very much. Pardon? Teaching practice we have to, no. Okay, we'll complete two teaching practice and go. Okay, Aisha and Rahul is left out. Okay. Time is there. What's the time? Take 10 to 50 minutes. 3:30. Rahul, you're not ready, huh? You're not ready for the presentation because tomorrow they'll be busy writing test or okay. Ma'am. In the article discussion have used, the paper will be given to everyone. What was the time he's asking about the time for aluminium and Just read it.
Ma'am, it is there in the slide, that big table, but it is the font is less.
Table is very small, you are not able to read.
Or ma'am, in the graph also it is there.
Which graph?
Bar diagram, no? No, bar diagram. This one. Every electrode, if it is 1 centimeter electrode gap and 2 centimeter electrode gap, what is the optimum time? It is written on the top. So that black color is aluminium. First one is 1 centimeter inter electrode gap and second is 2 centimeter. Copper is blue, AC1 is green, AC5 is red and AC10 is magenta. So from that you can see which is the optimum reaction time to get maximum removal of COD.
So reaction time is everything is shown here. Only thing one point I have electrode here, everything is very the electrode distance was taken. If electrode distance when we are reducing the distance, what happens? Performance will be high or low? Low. When we reduce the distance between the electrode, the performance will be high or low? High. Because that the influence of the electrical field will be there, then the more performance will be happening. So he has studied at two different electrode distance, one is 1 centimeter distance, one is 2 centimeter. He wants to confirm that 1 centimeter difference is having good result compared to the 2 centimeter because electrode distance as they are very close, that will be having more performance compared to 5 degrees. That is fine. They have direct influence on the performance, like our electrical field, electrical potential. He has used 30 volt here. 30. So these are the reactions.
Asking of the
Yeah, yes.
what the temperature?
It should be high temperature. Okay,
1100 because aluminium and copper is molding now. We will be taking the ratios like if you are taking 1 kg of for molding we need 1 kg total minimum. So I am taking if it is AC10, I will take 900 grams of aluminium, 100 grams of copper, and both will be put in the crucible, and that is induction furnace. We use induction furnace for the melting, so that after like 1100 degrees, it will be in the molten state. In 700 degree itself, aluminium will be in the molten state. Copper needs more time. So for the surplus like 900 itself, it will start melting. It's like around 1100 we get. So the entire system is in the liquid form. Both will be kept in the same crucible.
Because 700 800 is sufficient for
Aluminium to
but copper needs
high temperature.
So it is both and having high temperature. So both will be.
Both will be melting the same crucible.
Now what's it? Yeah. Actually, I was thinking like that. Means I assume like that. Aluminium has to be molten separately. Copper will be liquid phase now. Then all we are making maintaining the
Ma'am,
ratio
that
between cement
we will be measuring the quantity before melting, no? Like 900 is to 100, like 9 is to 1. Ratios will be taken by weight. And the uniformity of the alloy is determined by the process is called stir casting. When the entire circuit is in molten stage, we have a stirrer which is kept above it, and we provide some mixing. Yeah, we can't keep it. It's very high temperature, so some agitator like thing will be inserted inside and provide mixing so that the entire liquid form will be homogeneous, like somewhat identical all the points. So then only we have to pour it into the cast.
first you are just melting it,
Ah.
then you are stirring to make a homogeneous
Homogeneous
mixture,
mixture.
then
Then
only
only
you take
pour.
to the casting.
Just inside. It's a inside
I have a
the
doubt regarding the traction factors provided in the system. Is that there some equations of
Yeah, plus or minus
Yeah.
that is actually that is very important again. Whenever you come to paper and same paper, they will be asking for the concurrent values. Like when we do calculation or in our chemistry labs, we take 2 3 times. So we have to repeat the experiment minimum 2 times. First time, for example, if you are having some kind of see, this is 83.2 plus or minus 3.7. The meaning is the value, the initial value and final value. Get taken 2 3 times. No, the values will be lying between this plus or minus 3.7. That has to be done. That is called error also. Without this, they will not answer. They want us to repeat at least minimum 3 times per stage.
extreme condition that is all right. Results also.
No, yes, actually,
Ah,
the same experiment has
so
to be
that is
conducted.
also
Same
the-
experiment has to be conducted minimum 3 times to know the error values. So we can't tell that exactly the percentage of removal was 86%. Okay, there will be some plus or minus. Okay, that should the range should be given in the paper contributions.
And in this one, AC1, AC5, AC10 has been tried.
Yeah.
Then what about the higher, like AC15, AC20, what happens?
Actually, copper is costly also. Okay, copper is not so it's not having dissolution property, and it's very costly also. It's very hard in nature. Everything. Only thing, life of aluminium. If you want to do something in increasing the life of aluminium electrodes, compared to iron, aluminium is most commonly used. Do you accept that? Compared to iron, aluminium is commonly used. And aluminium also has the electrode loss problem. Okay, and it has good performance. Performance wise, aluminium is good. And but it has some sacrificial anodes, it has some loss. That loss how to minimize? How can we use the electrode for a long time? That is the focus. So we should try to incorporate some other alloy material like copper or something, only small titanium also. We can include only in small quantity. When we keep on increasing copper like 50-50, aluminum 50, copper 50, it unnecessarily increase our cost. Performance may be increased. Okay, I don't know. We have to do some compromising. Okay, because of performance, we can't do very costly methods or costly efforts we can't select. Okay, economical balance should be there. Environmental impact should not be there. As well as performance should be high. Like that, we can balancely tell that our research is fitting to the current need.
Ma'am, actually, we can't mix more percentage of copper to make this catricate alloy because maximum, according to some chart, mechanical chart, if you are mixing two metals, to make a stable metal, we can't mix 50-50 percentage of aluminum and copper together or 20-80 percentage. Maximum possibility with a better strength of mixing is like 12 percentage copper. Okay. Because I made 15 percentage also, but the electrode that I got is like just like brittle. It will break very fast. So the optimum time, optimum concentration, because of that only I stopped till 10, AC 10. If I go on beyond 10, what I observe is that the alloy will not be stable. It will collide with a small voltage. Because of that.
One thing I want to ask you, how many it is like asking myself, now regarding the environmental impact, again it's a metal element, like metal and aluminum is copper. You are losing long time so that you are trying to reduce the environmental impact. So what will be your next study so that participants may come to know how to balance the environmental impact problems?
Actually,
Pure metal, no? Aluminum is pure metal, copper is pure metal. Can you tell some ideas so that how can we minimize the
ma'am already explained about the inter electrode gaps, the reaction time, everything. No. the main demerit of using electrocoagulation process is that we will end up in the metal sludge generation, and we again have to do some process to make it remediate without making any that much effect onto the environment. So what we have to do is that we have to convert that metal to some value added products. No, so currently we are having the idea which is focused on the product development from the sludge which is generated, and we communicated one paper also regarding the same. I don't know whether we have to explain. We started out making products like pigments using a
What is telling us, we know that the railroad is having loss. In that sludge, no, we have a lot of aluminum materials, copper materials, a lot of things material. That is hazardous. Actually, we have taken the products from the water phase, and we are now disposing in terms of solid phase. That's not good. So, this trying to do zero discharge. Zero discharge means no pollution should be given to the environment. That concept is telling the sludge, whatever is left of the electrochemical sludge. That sludge, it might be used for some beneficial things like biofertilizer preparation. Like yesterday, the Prima plant sludge will be there, after the biological, because that is having a lot of biological content in it. It is very toxic also. But they are using for farming purpose. We don't know very good gardens there by using the sludges, wastewater, all. It is happening, but it is not technically, this is not proven. They simply use because they don't want to waste the sources. They are using the wastewater, there is after some cleaning treatment. But here, what happens technically, or more focused on research is taking the sludge material, some ratio of industrial sludge will be taken, and some ratio is electrocoagulated sludge. What is using? They are not using electrocoagulation, they are using biological chemicals. From that, the sludge will be having biological properties. That biological sludge plus this electrocoagulated sludge, what is having, then plus some what is that, industrial waste or some vermi compost, all those things has been joined. Some ratio they are trying, the work is going on, and these are the questions for doing that. So they are trying to develop some fertilizer, commercial biofertilizer. It's accepted, it is accepted everyone, also we have the properties of fertilizer. The commercial fertilizer we are in trial now, they are using coal wash, coal industry wastewater, coal wash slurry they have used. This sludge we are using to get some waste. So we should try to do like that. Waste is generated. Now we have to try to take one more. Ramesh was telling that first lecture, the electrochemical sledge has the metal content in it, and she's using for some brick.
ma'am, already some work published regarding the same only. Brick manufacturing, they are instead of clay, they use this.
You have to find an application for the sludge development. You have to know the toxicity. The sludge, what you have after this process, after this particular process, it's going to have aluminum in it, it's going to have copper in it. What will be the toxicity? Okay, this having toxicity, high toxicity, then we can't dispose anything. In that case, at least we can convert into some other product. Okay, like composite brick or some fertilizer. Fertilizer means some plants will be tolerant to some extent to the.
Meanwhile, as a token of appreciation, I would like to welcome Bhuvaneshwari Madam to receive the memento. I also welcome Dr. Mohanraj V to hand out the memento.
Sir is not here, but I'm very happy to receive from today. I don't know, he started working in social studies from him only, and he was the main person for all the equipments what we have purchased. It's not like that rather than now they have got innovative project or they have fund with them, they are purchasing, but most of the equipments was purchased under you. Everything he only knows, okay? So I'm very happy. Now actually he's in a private college. Actually, in a private college, but soon I'm expecting him to be in a very great position better than me. Okay? Actually, he deserves all that. He has a lot of practical knowledge. When you ask anything silly, he will tell 10 answers for that. I will tell no, no, tell me this alone for me. I want to know whether this is happening or not.